Okay, in this video I want to discuss the use of motion capture data with machine learning. This is a field that has many applications, such as, for example, if you want to classify this data, you could use this to control animation software or human-computer interaction in general, surveillance applications and others. And if you want to, you could use also this to synthesize motion for animation or robotics. And most of the time you need a big database of motion capture data to train the machine learning approach you're using. And this data has some problems. So this data comes in different file formats. If you're using royalty-free data from other institutions, and even if you're producing the data yourself, there's probably different equipment will give you different results, different file formats, different skeleton descriptions, and your actors might have different proportions, so proportion variations, they might move differently, and then you have the issue of the character being placed somewhere in space and going in a certain direction or orientation. So for example, if you want to do a classifier for a walking motion, and in your database all your characters walk from left to right, and if by any chance you're classifying the motion of someone walking from right to left, you would fail to do it, so you'd have to convert this global position to a local position. You could have naming variations in the data, and you could also need to extract some implicit data like ground contact, foot to ground contact, and also like speed of the joints, or maybe all you have in your data is the orientation of the joints, but you would also need the position of them, and then you need to extract that somehow. So you could do all of this in the package you use for machine learning. For example, I am using most of the time MATLAB, and you could do this in MATLAB. It has a script language which is kind of neat. It's easy to use, but it's easy to see what you're doing, and because most of the time all you can do is plot the data, and this is not sufficient to see if you're doing the correct calculations. And also another problem is that many machine learning are frameworks. They are more generic. They're not geared towards animation and animation data, so they lack support for industry standard formats like FBX or BVH. So there's these two kind of problems with the data itself, and also with the frameworks we could use to transform this data or manipulate this data. So to avoid some of this, I'm using a Fabric Engine as a framework to do the pre-processing of my data before moving the data to the machine learning framework I'm using, which in this case is MATLAB. You could use other stuff. And the reasons for using this application is that it's geared towards computer graphics, so it has many other tools you need to manipulate this type of data, especially the industry standard formats. And it's very easy to prototype. It has its own language, scripting language, which is called KL, and you can access it through code directly, but it also has a nodal interface, so it's very easy to get into. And you could also access it through its standalone development environment, which is called Canvas, or you could also access it through C++, Python, or even some professional animation software like 3ds Max or Maya. So I'm going to try to give you an overview of how to treat this data in Fabric Engine. One thing to keep in mind, it's a commercial application, but it's free to individuals, so it might work for you or not. So if you want to learn exactly what Fabric Engine is, you can go into their website. I'm gonna just show the parts that are relevant to me, but it's probably more useful if you can go there and find out for yourself if it works for you. So basically, this is the canvas, which is like a developing environment for Fabric Engine. And here you can see a scene where this script right here is loading some data here from a Alembic file, which is a very standard in the animation industry, and it's manipulating this data and then outputting this as a mesh, then drawing this mesh. Okay, so we can see here I can, for example, change these nodes and change how they look procedurally. And as I said, you can access data through this interface, but you could also use professional animation software and use the same code over here. So for example, if I click on this frog, it looks like it lives here in the Maya scene. It fits here perfectly. If I click on it, I'll see it's actually a canvas graph. And here you see it's pretty much the same graph from the canvas file. I actually just copy and paste from one to another. You can do this. For example, I can copy this node and paste it right here. And here you can see it's just pretty much the same code. I can double click this and move here, and you see it's pretty much the same thing I have had over there. And just for driving the point home, you could fire up the Fabric Engine prompt here, which is just a regular prompt with the environment variables from Fabric Engine set up. And I could just run this Python script, which is right here. So you can see it's a Python script that imports Fabric Engine as a package and then loads the frog Alembic, which is resources frog, which is exactly the same frog that we have right here, resources frog, and then it outputs its the positions of all the vertices. So if I run this in here, let me do this, which is not here. Okay, just let me pause. Okay, so now I save the file to the correct folder, and if I just run this, you can see it's gonna load first Fabric Engine, and then it's going to load the frog eventually, and after it does, it's gonna spit all of the vector positions of all its components. There it is. Okay, so this is Fabric Engine. It's just a place where you can manipulate your data and look at your data and then feed out your data to other programs. It's also extensible, so you could create your own packages, just like you would do in Python, for example. And what I have done here is create a package called Fabric Utils, and I have created a lot of nodes which are used for manipulating motion capture data. So it would make your life easier for this specific application.